Hello everyone, my name is Vivek Pandey. I am solution architect at ZettaScale Technology. So earlier I thought that I will present about RMW Zenoh, but now you have a lot of feel about RMW Zenoh because Yadu, our colleague from Intrinsic, Yadu and Angelo Corsaro already talk much more about that. So we are planning to give the live demonstration about that. But before that, we give some highlight about that. So RMW Zenoh is an alternative open source for middleware for ROS2. So if we have a middleware in ROS2, then why we need alternative middleware? So we will cover into our next slide. So here you can see this is the stack of ROS2. So it is provide the modular architecture where you can use this into developing any distributed robotics application. And for the communication, because you develop your robotics application, then you need middleware for exchanging the data. So here earlier we have the DDS, and currently we introduced the Zenoh as a middleware technology for ROS2. So DDS was chosen for good reason. So it provides the pub-sub type of communication. So in ROS1 there was a huge problem regarding that, because there was a master node who discovered all the nodes, and after that the communication happened. But when master node goes down, then all the communication collapse. It is stopped the communicating. So if you want to recommunicate, then you have to restart all the systems. So that was solved by the DDS, and some other reason it was proven technology for the defense and aerospace. But when you come to DDS was very popular because of wired. It works well in wired communication, where you have the plenty of resources. There is no constraint on the network bandwidth and CPU utilization like that. But when you come to the robot to robot communication or wireless communication, where it creates a lot of problems. So we come to, so there are other problems like the beauty of DDS was discovery. But when you come to the wireless communication, then your beauty becomes hell, because DDS rely on the pub-sub communication, and it use UDP multicast for the discovery. So when you have the loosey networks, or you have the lot of packet loss, so wireless communication have lot of packet losses. So for that, it create a lot of problem. So Intrinsic did analysis for different protocols to evaluate which one protocols may suit for the robotics communication for next generation. So they come to know that that Zenoh is best fit for that. So why these are the different protocols that evaluated, and they have very detailed metrics about that, what parameters they use for the analysis. So after that, they come to know that Zenoh is best fit for that. So here you can see that there are different protocols, there are different parameters, and all the results that came. So you must go with that report. So that is available on the discourse channel, ROS2. So now we come to know about, so I recall that what the Zenoh already covered by the Angelo and Yadu. So Zenoh is a pub-sub query protocol that unified data in motion, data at rest, and same time it provides the geographical transparency. You can store the data into geographical transparent way. When you want the data, then you can query the data, and we have the queryable, so you can get a reply, and there is no need to know about the geographical transparency. So here we come to the RMW Zenoh. So this is communication between hosts. So we have a robot. Within robot we deploy. We have different nodes or different application running. So they need to communicate to exchange the data. For that we use the Zenoh. So for the discovery, most of the time, all the time we use Zenoh router. So what the router did, so it did all the discovery. So we have discovery and after, on the TCP network, and after that we use the TCP peer-to-peer communication within the node. When our router goes down, then there is no problem with the within the communication of the node to node. So again, if you want to the communication between robot to robot, then you can directly connect to the one router to another router, and rest of the discovery will happen by this host 1 discover all the nodes and host 2 discover other nodes, and they will exchange the discovery information to each other, and in this communication the discovery and transport will be done by the router to router. So I think we have limited time, so we need to go with the live.
Okay, so thank you, Vivek, for the intro.
Thank you.
What we decided, as there were lots of questions, was, okay, let's actually show how it works. There are concerns what happens if the router crashes and then restarts. So instead of talking, should we take a look at it?
Absolutely.
Okay, so what did we cook for you guys? We have 2 container runnings on this machine. We want to do something more complicated, but then we said, okay, let's go back to the basic, and you'll see we'll simulate as if we had multiple robots, potentially even talking through a LAN. So we have 2 containers here. Notice that one is exposing port 8449 in my Mac, and the other 8448. And recall the prefix, it's 14C and 4A3. That will be interesting when, to know which shell I'm running. Now, let's get to color coding. One container is this one. This is the container 14C, okay? In the red shell, I'll be running the router, and in the other, we'll see what we'll be running. And the other container has a slightly different color coding, light colors for, let's say, the applications, and we will be starting the router here on the green shell, okay? So, guys, what shall we do? What is the yellow word example in ROS?
Oh, we usually start with the talker listener example.
I think we start with the workshop example 1.
Talker and listener. So
yes.
First things to do, as we saw in Yadu presentation earlier this morning or in the workshop, is to start the router, right? So the command is ROS2 run RMW Zenoh CPP RMW Zenoh D. So we start the router, that's running, as you see in that shell. And now let's start, let's say, a listener here. Oh my God, it's not receiving anything. Of course, we are not running the talker.
Yeah.
And how about we start the talker? And
all right.
Unsurprisingly, we have data. Now, what did we show today? We show a certain topology, right? Would be good if we could see that topology. So let's see what we can see here. I'll real quickly connect a tool to the container. So that's the 8448. Oh, actually, I was running a few more things.
So while Angelo clears that up, I could just explain the container topology really quickly.
Go ahead.
So we want to show 2 different robots or 2 different hosts, and each robot or host running its own set of ROS nodes and how they can talk to one another. Since we don't have a robot and we just have 1 computer today, we're doing this through containers. So just think of 2 containers as 2 different computers or 2 different robots.
Okay, so what I've done here, because we will use this next, I've started a tool, which is the tool. I have another router running locally. We will see why we will use this. And then here, we have a bunch of ROS nodes that are communicating, okay? If I wanted to see the ROS nodes, well, actually, we could see the Zenoh topics, but we'll discuss, if we have time, the mapping between these and the ROS topics. But if you wanted to actually look what is happening in the ROS world, we could also look at that. Domain 0, so here we see the listeners, we see the topics, okay? And actually, if we wanted to see the graph, we could see the graph, okay? And so that's precisely what you're expecting, and that's how it works, okay? So I will close this. And now,
This is boring stuff, Angelo. Everyone's done talk a listener.
Should we do some killing?
Computer.
Oh,
yeah.
no, well, don't worry. We are just going to kill what? A router?
Sure.
Yeah, let's kill a router. Let's kill.
So a lot of you who might be using ROS1 might get flashbacks to the router crashing and then having to restart all of your nodes. Even though we're bringing back this concept of a router with RMW Zenoh, we want to show you that it's not the same. The router is purely used just for discovery, and once nodes discover each other, all of the transport is still peer-to-peer.
Yeah.
So I think for those who use the ROS1, then they are surprising that without the master node or without the routers, we are getting the data.
And actually, we can things now, let's play a little bit more. So what I'm going to do, so now obviously we killed the router. So you see I have the tool connecting to my Zenoh router running, not in the container, but this run router here is running on macOS, okay? And what we are going to do actually, we are going to start a router in the other container, okay? We are going to start a listener here, which, guess what, won't be receiving any data because topologically, right, we are not connected. So if this is actually the topology that we have currently, right? You have the router on the, let's say, on this side, the listener, right?
Yeah.
But this robot is disconnected from the rest of the network. To reconnect, what we do, we restart the router, okay? And let's see what happens on the other side. Woohoo! We are receiving data. Okay? You understand? You can do it even loud. I mean, that doesn't
I
happen.
think only one understand that what Angelo is doing.
Okay, so let me actually untangle this. So we will see the actual topology that is going on, okay? So what is happening, right? This is the tool that is connecting to my Strawberry, which is the Zenoh, the Zenoh router running on macOS. These are the two routers, let's say, running on the robots, Robot 1, Robot 2. And so before, there wasn't a communication path, so no data was flowing. Then we restarted this router, and obviously the communication restarted. If I kill this router, right, obviously the communication within this robot will continue, but the other robot won't be receiving data, which is absolutely normal. The system heals, and the data flow resumes. Right? Smooth and easy. Okay? And again, I think it's very important to realize that in here we're playing with containers. Whoops, that's not what I wanted. We are playing with containers, right? But nothing stops us from Strawberry being deployed somewhere on either an edge server or the cloud, right? And those two robots being God knows where, okay? But we can do better, can't we?
Absolutely.
So Angelo, can we see the topic list are like that?
Sure. So Yadu, I'll give you the console. Have fun.
Oh boy.
Enjoy. Hold on. Use this side here. Here we go. You can use that one.
All right. So this is going to be a quick test of usual introspection that we do in our ROS2 system, just to make sure that it works across these different containers, which in theory are different robots. I'm going to run through a few standard commands, ROS2 node list, and we see two listeners, one on this host, one on the other host, and we see one talker here. We can even get some information on each topic that's being published, so let's take a look at what topics are running. We see that the main topic of interest is chatter, and if we want to get some more details about it, we can run ROS2 topic info. And if I can make this bigger, starting from the top, we see there's a single publisher, and we have 2 subscriptions. So we're also seeing a lot more information about the subscriptions. We can look at their quality of services, type of messages they're sending over, and a lot of other metadata. And the cool part about this is this could be a robot that's really somewhere else in the world. And typically the way you would do this is you have ROS running on the robot, you might need a VPN and then a cloud instance somewhere else to bridge the data from your robot to like a warehouse or where your compute is. But now, natively with the ROS middleware, you're able to do all of this information without an extra VPN layer.
No constraints, as we were discussing this morning. So we don't have much time left, and there were 2 things we wanted to do. Yes. We want to do some more killing and to show access control. So I will start with the killing, not because but I think that you have fear, right? And we need to remove those fears. So what are we going to do is the following. We're going to kill the router, okay? It doesn't complain, so communication continues. Now suppose we kill the listener, okay? So the listener is gone. And now we try to restart the listener. What happens, Yado?
It's going to complain that it can't find the router. And this is a feature that we have in RMW Zenoh by default. We want this router running. And as soon as Angelo starts the router, we're going to see the listener come back online.
Okay, so, I mean, why, again, sorry for the violence, but nobody was hurt. The router actually enjoys that. But hopefully this addresses the many questions that we had, right? So do I have ordered? No. So you just have the good side of it. Yeah.
Yep.
So maybe, can we do the access control demo, or are you kicking us out? Time out? Okay, so maybe what we can do, as we dash away, okay, we just show you, instead of the access control, a video of the downsampling, because the principle used is very similar. So here you see Julien configuring downsampling on some video streamed from a robot, and you will see literally one video, the local video, moving smoothly, and the other one obviously being downsampled. All of that can be done by configuration, and as we discussed at the workshop and quickly today, having a router in the robot becomes your point of integration, decided what gets out, how it gets out, how you do security, and so on and so forth. So, well, thank you. And I think the call for harm is, this is planned to become tier 1,
yes,
right?
By Kilted, which is May 2025. We're working on getting features like access control in, especially security features, which will be critical. And we need everyone's help in testing RMW Zenoh. I think it's at a state right now where it's ready to deploy for some robotic systems. So we'd love to get your feedback on it. And if you find any issues, we'd love to hear about it.
Okay, so thank you for helping us testing and maturing this. And thank you for everything.
Thank you, Angelo. Thank you, Yadu.